Hello students, today we continue with terminology of worm gear, that is tooth pressure angle. It is measured in a plane containing the axis of the worm and is equal to one half the thread profile. That angle, pressure angle, is as shown in figure number 1 that we already discussed. The following table shows recommended value of lead angle lambda and tooth pressure angle phi. If we see here, this lambda is if 0 to 16 degrees, then phi becomes 14 into half degrees. If lambda is 16 to 25 degrees, then pressure angle phi becomes 20 degree. If lead angle is 25 to 35 degree, then phi becomes 25 degree. And if lambda, that is lead angle, is 35 to 45 degree, then pressure angle phi becomes 30 degree. If we consider for automotive applications, the pressure angle of 30 degrees is recommended to obtain a high efficiency and to permit the overhauling. If we see the next point, that is normal pitch. It is the distance measured along the normal to the threads between the corresponding points on the two adjacent threads of the worm. If we consider mathematically, then Pn is equal to Pa into cos lambda for single start, and for multi-start threads, normal lead, that is Ln, is equal to L into cos lambda. If we see helix angle, it is the angle between the tangent to the thread helix on the pitch cylinder and the axis of the worm. It is denoted by alpha w. Next important point is velocity ratio. It is the ratio of the speed of worm, that is Nw in rpm, to the speed of worm gear, that is Ng in rpm. If we consider mathematical equation, then velocity ratio is equal to Nw upon Ng. Let L is the lead of the worm, Dg is the pitch circle diameter of the worm gear, and we know the Vw is equal to lead into speed of worm, that is Nw divided by 60, and linear velocity of worm gear, that is Vg, is equal to pi into Dg into Ng upon 60. Since the linear velocity of worm and worm gear are equal, therefore we equate these two equations. So L into Nw upon 60 is equal to pi into Dg into Ng upon 60. And if we see the ratio of speed, then Nw upon Ng is equal to pi into Dg upon L. We know the pitch circle diameter of the worm gear, that is Dg, is equal to module into number of teeth on worm gear, that is Tg. Velocity ratio is equal to Nw upon Ng, so we substitute the values, that is pi Dg upon L is equal to pi into m into Tg divided by L. In place of Dg, we substitute this m into Tg. So, but we know that pi into m becomes Pc, so Pc into Tg divided by L, which is equal to, but we know that in case of worm and worm gear, Pc is equal to Pa, so Pa into Tg upon Pa into N, because lead is Pa into N. Then Pa gets cancelled, so Tg upon N is the velocity ratio, where N is the number of start of the worm. So we may also say that velocity ratio is the ratio of number of teeth on the worm gear to the number of starts of the worm. So in this way we finish the terminologies in case of worm and worm gear. Now we see number of starts to be used on the worm for different velocity ratios. If we consider velocity ratios is 37 and 36 and above, then number of start N is equal to 1. If velocity ratio is between 12 to 36, then number of starts becomes 2. If velocity ratio is between 6 to 12, then number of starts becomes 4. Now different proportions are also there, so we see two different tables, that is first table is related to proportions for worms. The following table shows the various proportions for worms in terms of axial or circular pitch Pc in mm. We see different terms like particulars, that is normal pressure angle, here single and double threaded worm and triple and quadruple threaded worms, that is 3 and 4th threaded start or threaded worms. So phi becomes 14 into half degrees for single and double threaded worms. For triple and fourth start threaded worms, this phi becomes 20 degree. Second, pitch circle diameter for worm integral with the shaft. This becomes 2.33 into PC plus 10 into mm for first case, and 2.35 into PC plus 10 mm for second case, that is same. Third, pitch circle diameter for worms bored to fit over the shaft, that is 2.4 into PC plus 28 mm, and same for second case also, that is 2.4 into PC plus 28 mm. Fourth, maximum bore for shaft, that is PC plus 13.5 mm, and same for second case, that is PC plus 13.5 mm. Hub diameter is 1.66 into PC plus 25 mm for single and double threaded, and for triple and four threaded 1.726 PC plus 25 mm. This becomes different. Face length LW is equal to PC into bracket 4.5 plus 0.02 into TW, and same formula for second case also. Depth of tooth, that is H, is 0.686 into PC, and for second case it is 0.623 into PC. Addendum, that is A is equal to 0.318 into PC, and in this case 0.286 into PC. Now if we see the formula for pitch circle diameter for worm, that is dW, in terms of the center to center distance x, then dW is equal to x raised to 0.875 divided by 1.416. This is empirical equation for finding the value of dW. And here dW is equal to 3 times of PC, where PC is axial or circular pitch. In this way we finish the proportions for worm, and now we see the second table, that is proportion for worm gear. Following table shows the various proportions for worm gears in terms of circular pitch, again that is in mm. First is normal pressure angle phi. Then for first case it is 14 into half degrees, and for second case it is 20 degree. Outside diameter, that is DOG, it is DG plus 1.0135 PC, and for second case DG plus 0.8903 PC. Throat diameter, that is DT, is equal to DG plus 0.636 into PC for first case, and DG plus 0.572 into PC for second case. Face width B is 2.38 PC plus 6.5 mm for first case, and 2.15 PC plus 5 mm for second case. Radius of gear face, that is RF, is equal to 0.882 PC plus 14 mm, and 0.914 PC plus 14 mm for second case. And last is radius of gear rim RM, that is 2.2 PC plus 14 mm and 2.1 PC plus 14 mm for the second case. In this way we finish the terminology and proportions for worm and worm gears, and here we stop our lecture. Thank you.